Welcome to a behind-the-scenes look inside a lubricant blending plant. In this tour, we'll follow how base oils and additives come together to become finished lubricants. The products made here protect engines, gearboxes, hydraulics, and more. Precision, cleanliness, and process control drive consistent quality. Let's step inside and see how it all works. This is lubricant blending, end-to-end. Lubricant blending combines base oils with functional additives to meet performance targets. Base oils provide the fluid foundation, viscosity, and film strength. Additives deliver detergency, dispersancy, anti-wear, extreme pressure, and oxidation control. Mineral base oils originate from refined petroleum. Synthetic base oils are engineered in reactors for specific properties. Blenders select the right base mix for viscosity grade and service conditions. Additives are precisely dosed, then mixed into the base oil. The result is a finished lubricant ready for testing, packaging, and use. Operations start at storage. Dedicated tanks hold base oils and additive concentrates. Fluids move from storage through transfer pumps into blending vessels. Pumps supply controlled flow and head to maintain steady transfer. PLC and SCADA systems supervise valves, temperature, levels, and flow. Real-time trends and interlocks ensure safe, repeatable operation. Operators adjust set points and verify sequences via standard procedures. In the field, technicians verify levels, valve lineups, and tags. Flow meters confirm dosing rates during transfers and blending. Thermic heaters stabilize temperature for optimal mixing and additive solubility. Basket filters capture impurities before and after blending. Routine inspection and change-out maintain cleanliness and flow. Clean-in-place steps reduce cross-contamination and protect quality. Plants use mechanical blending, pump circulation, pulse stirring, and continuous blending. Mechanical blending relies on in-tank agitators for bulk mixing. Agitator design, speed, and baffles drive shear and turnover. Operators tune RPM and time to achieve homogeneity. Pump circulation pulls from the tank and returns flow to promote mixing. Flow control and nozzle placement improve turnover and additive dispersion. Pulse stirring injects timed air or gas pulses to agitate the bulk fluid. It reduces mechanical complexity while maintaining mixing energy. Continuous blending meters multiple feeds into a mixer for constant output. The design delivers repeatability with tight residence time distribution. Method choice depends on product type, batch size, energy, and flexibility. Plants often combine techniques to balance quality and efficiency. First, select the base oil source according to the required viscosity grade. Next, measure and prepare additive packages for accurate dosing. Dose additives under flow control to match the recipe. Begin blending with the specified mixing speed and temperature. Maintain mixing time until the batch reaches uniformity. Pull a sample and verify viscosity against the target grade. Confirm flash point and other safety-critical properties. Package products into bottles for retail or drums for industrial use. Labels and codes ensure traceability throughout the supply chain. Finished goods are staged, palletized, and shipped to customers. Quality depends on dosing accuracy, water content, air bubbles, temperature, cleanliness, and mixing time. Accurate dosing keeps additive balance on spec. Temperature control, often 55 to 65 degrees Celsius, improves solubility and blend stability. Minimize entrained air to avoid foam and measurement errors. Clean equipment prevents contamination between batches. Mix for the specified time and verify uniformity before release. Automation boosts throughput and consistency. Data analytics tracks quality trends and process capability in real time. Insights cut energy use and optimize cycle times. Sustainability drives adoption of bio-based stocks and recyclable packaging. Together, these advances define next-generation blending. Digital workflows standardize procedures and compliance. The future is smart plants connected by IoT. Digital twins enable predictive maintenance and faster optimization. Equipment health is predicted before issues impact production. Eco-friendly lubricants reduce environmental footprint. Smarter, cleaner, and more efficient blending is on the horizon. We've seen base oils, additives, blending, testing, and packaging. That's the lubricant blending journey, from raw materials to finished products. For more plant operations and engineering videos, subscribe and explore the next episode.